I welcome you all for the wireless communication lecture module. In this lecture, we are going to discuss about diversity combining techniques. So, diversity combining techniques is most widely used in MIMO antennas, that is multiple input and multiple output antennas. In MIMO antennas, at the transmitter side, we have the single information has been transmitted with the help of multiple copies. These multiple copies will travel at a different path and finally it reaches the receiving end. So here, how the receiver is going to combine the signals, n number of we have received n number of signals, how the receiver is going to combine these n number of signals so that it get back to the original information, that concept is called as a diversity. Okay, so the information has been transmitted at a different path. Okay, so it reaches the destination at a different time delay, and the signal will undergo different fading effects. So, and it has a different phase shift also. So, how we are going to combine the signals at the receiving end? That concept is called as a diversity concept. The aim of the diversity is to improve the received signal quality at the receiving end. That's the concept. Okay. So how to ensure that the received signal quality has to be enhanced. For that, we have certain procedures or we are maintaining certain concepts or algorithms that is called as a diversity. Okay. So the diversity can be majorly classified as, one second. The diversity can be majorly classified as a micro diversity and a macro diversity. So micro diversity is nothing but the small fluctuations in the signal. That diversity is called as micro diversity. So in the micro diversity, normally it considers a small fading effects. So to remove the small scale fading effects, we are using a micro diversity. So again, the micro diversity has a five common types. Okay, first is one is a spatial diversity. Here, the several antennas or elements are separated in terms of space. Okay, and then temporal diversity. Here, the transmission of signal in different times. Okay, time slots. And then frequency diversity, transmission of signals at a different frequency. Polarization means the transmission of signals at a different polarization. Angular diversity means multiple antenna with a different antenna pattern. So we are the different signals have a different radiation pattern or different, everything will be either it will be varying in spatial or it will be variable in temporal, frequency, polarization or diversity. How we are going to combine these multiple signals, that is called the diversity. So this is about the micro diversity. So normally micro means a small fluctuations in the received signal. This micro diversity occurs because of a small scale fading effects in the channel. Okay, then the second diversity is macro diversity. Macro diversity is normally occurs because of a large scale padding effects in the channel. And then there are a few diversity combining techniques is that. Okay, so we'll look at one by one. The first diversity combining technique is selection diversity. So as look at the block diagram, so we have a n number of transmitting antenna, m number of transmitting antennas. Okay, so with the help of m number of transmitting antenna, the information has been transmitted at the transmitting end. Now at the receiver end, there m number of receiving antennas receives the signal. Okay, so this is the concept. Now, among these m number of antennas, okay, the antenna which have a higher end SNR will be selected. We have received m number of signals, out of which we need to select any one signal or we need to combine all the signals. So out here in this selection diversity concept, we are going to pick one signal. Okay, that signal which has a higher SNR. So with that signal, we are going to extract the original information. That concept is called as a selection diversity. And the second diversity concept is scanning diversity. So here the receiver is going to scan for the m number of signals. Okay. So here we are setting with the help of comparator. Here we are setting one threshold value. So among m number of signal, which signal has a value which is greater than threshold, that signal has to be detected at the receiver. With the help of that signal, we are going to extract the original information. So we are going to set some threshold value. The signal which has greater than the threshold value has to be considered and that has to be received From that we are extracting the original information. That is called as scanning diversity. And the third method is maximum ratio combining MRC diversity. So here we are setting a weights for the all the branches. Okay, so depends upon the weight. So we are going to combine all the SNR values. Okay, so output SNR equal to sum of the all the individual SNRs. So always if you are combining all the output SNR, the SNR value is greater than the threshold value because we are combining all the received signals. So obviously the received signal will be greater than the threshold value. So this type of MRC technique mostly widely used in digital receivers. So MRC is the best technique which is compared to the previous techniques where you selection and the scanning diversity technique. And the fourth one is equal gaining combining. In the MRC technique, we are going to combine all the signals with the weights, all the signals which have some weights. Instead of that equal gain combining, we are setting the weights to the all the branches. We are making all the branches weight as unity weights. Okay, so then only we can combine all the signal with respect to co-phase. So here, if we are combining all the signal now, that signal may be in a may either produce a constructive interference or destructive interference. So here we are setting all the unity weights so that all the signals are in a co-phased. So we'll have a create a constructive interference which has a more possibility when compared to the MRC technique. So the performance of the equal gain combining is marginally inferior to when compared to the MRC technique. So this is about a diversity combining technique. Diversity means we widely used in a MIMO. We are sending n number of transmitting signals from with the help of m number of antennas. Same copies of signal using m number of antennas. So at the end, we supposed to receive that and we need to extract the original information. So that concept is called as a diversity. So diversity is normally used to improve the received signal quality. Two types of diversity: micro and macro. Micro is with the small scale. Macro is compared to the large scale. Again, there are four combining techniques are used. Selection diversity, we are going to pick with the one signal which has ISNR, and second one scanning diversity, we are going to scan the received signal out of which the signal has greater threshold, that will be considered. Maximum ratio, all the weights are combined, all the SNRs are combined together to receive the extract, and finally all the weights are set to unity. Okay, so the signals are in co-phased so that we can extract the original information. This is called diversity